All right, we're here. This is going to be your triangle congruence proofs worksheet, and we're going to go ahead and get started. Okay. So the first thing that we want to do here is we want to look at our first problem. Okay, and we're going to look at the given and basically picking what we can do. They have marked it for us, so be careful about that you still have to prove the things that they marked. Now, we don't have to prove this side, but we do have to do something with perpendicular. And when I think perpendicular, I think right angles. And so when I think right angles, I'm going to think that we might use the HL, but it just depends. We have to prove this is HL. Okay, so I'm first going to write my statement here, and then I'm going to try to figure stuff out here. So we're just going to go ahead and write this down. Okay, you can of course write that on the same line if you can fit it. Okay, and remember on the test that this is important. You have to write down the information and you have to put given. Okay, and I like to draw lines. Okay, so we got all that given. So BC and DC is right here. Okay, and, well, they're marking right angles, but that doesn't mean right angles. So I'm going to go ahead and write that down, angle B and angle D are right angles. And that is just going to be the definition of perpendicular, is what we've been using. Okay, so let's see what we got so far. We got this side, we got an angle. Now we got to figure out another side. So BD is perpendicular to DE, and BD is perpendicular to AB. Okay, so we got all that taken care of. And so I don't actually see any way I can do this side. I do see this X, which makes me think of vertical angles. So I think my goal is to go ahead and get angle, side, angle. Because I got that angle, I got that side. Now I just need to prove that angle, and so that would be angle A, C, B is congruent to angle E, CD, and that is the vertical angle theorem. Okay, and so I think I got now this angle, and so I think I'm done. So I'm going to write, wait a second, I'm not supposed to prove a triangle. I did prove a triangle, so I'm going to go ahead and write that down, and then I'm going to show you the next step here. You might not have got the next step. So this is going to be triangle A, B, C is congruent to triangle E, D, C. And that is true because of ASA. Okay. And now I'm going to prove my last thing, which is angle A is congruent to angle E. And if you remember, we did have a theorem that stated that corresponding parts of congruent triangles are congruent. And A and E are corresponding parts, so we are going to use the CP, CT, theorem. Corresponding parts of congruent triangles are congruent. So that's how we finish it. So if you didn't finish it that way, I would. Okay, so moving down the road, let's go to the next one. Okay, let me get that set up so it's straightish. Okay, this time, okay, and I did that on purpose, but this time I'm going to make sure we are proving the triangles. We do have some given. The givens are marked. I see the X. Anytime I see the X, I'm thinking an angle. So I'm going to go ahead and mark what I'm planning to do. And I think that's going to be side, angle, side. That's what I think. And so we're going to check it off as I get it done. So BC is congruent to DC. Well, that is given. Okay, so I guess I have a side. We have AC is congruent to EC. That's also given. So I got another side. Now I just need that angle, and that angle is going to be angle BCA is congruent to ECD. Nope, DCE. And that's because of vertical angle theorem again. So I got my angle, and so I got my three things. So all I need to do is write my proof. Write what I'm supposed to prove. A, B, C, E, D, C. And that is because of SAS, side, angle, side. All right, we're moving. We're getting it done. Hopefully you've tried these before we got here. And hopefully you're going to have some questions for me if something's not working right. So I do like this paper, especially because it has thoughts. It makes you think of maybe to write something to kind of help you get this planned out before you start it. Okay, again, I read it this time. I'm proving two sides are going to be congruent. So again, we're going to start by proving the triangle is congruent and then finish with CP/CTC. And so I'm going to go ahead, they marked it for me, but I'm going to trace over it just to make sure we're doing things right. So we got YA is congruent to BA, and angle B is congruent to angle Y. Just go ahead and get that taken care of so we can get some points on the test, because this is an easy step. Okay, so let's look and let's plan this out. I'm just looking at this shape, and again, I'm seeing that X. It's going to come up a lot on this worksheet especially, and so I need to prove that. I already got that and I got that, so it looks to me like my final statement is going to be angle, side, angle. Okay, and so let's get it going, and here we go. Angle Y Z A. It's not right. That is incorrect. Angle Y A Z. That A has to be in the middle, right? Is congruent to angle B A C. Okay, I didn't fit it right. I apologize. All right, the reason that is vert angle theorem again. Okay, and so I think I got the next step. The next step is triangle. Triangle Y ZA is congruent to triangle B C A. And that's going to be because of the ASA theorem. And then I can prove, what was I trying to prove again? AZ, this part right here, is congruent to AC, this part right here. They are, based on my congruency statement here, they are, let's see, ZA, yep, and CA, yep. They are going to be corresponding parts. So I'll make my final statement here. Oops, mark through there. AZ is congruent to AC, and that is CPCTC. Corresponding parts of congruent triangles are congruent. All right, moving right along. Let's flip this over. And some of these are going to look a little different. This one is not going to use the vertical angle for sure. Let me tape these down so this doesn't move on me. Okay. So let's plan this out. I see parallel lines. Parallel lines make me think of alt interior angles, so I'm going to mark that. Parallel lines, I think alt interior. So I'm going to mark that down. And anytime I see basically a rectangle or two triangles touching, I'm thinking reflexive. So it looks to me like this is going to be side angle side. Okay, so I'll go through this. Let's write the... My corner's not taped down very good. Okay, I don't want it to move. So let's go ahead and do that. WX parallel to YZ. WX is congruent, sorry, to YZ. Okay, that's all given. Okay. And I found my straight edge, which is what I'd like to do a little better. All right, let's see here. Well, I need to prove those and that. So, they already established that those are equal, so that gives me a side. So let me check off that side. Okay, so it doesn't matter what you do next, but I'll go ahead and go in order because that sounds fun. So I'm going to go angle X, Z, Y is congruent to angle Z, X, angle ZXW, and that is because of alternate interior angle. Okay, theorem. All right, so that gets me angles, fine, and now I'm going to do side, and I like that. I think that means that ZX is congruent to ZX, reflexive. So the reflexive property, and I think we're done. I think we are done. Okay, let's see here. We're just going to write what they say. WXZ is congruent to YZX, and that is because of SAS. Okay, I forgot to check off that side, but we did it. All right, moving on. A little bit shiny. Okay. See if I can move some of that shine. Okay. So we're going to look at this page. Let's see. We've got a midpoint, so we're going to have to use a definition of that word to probably do something. And then we have those angles equal. So I'm going to go ahead and write this stuff down. And we're going to do L is a midpoint of Km given. Okay. Let's see here. So I'm going to start with, well, it's marked already, L and M. Okay, great. And then they actually marked this, which is bothersome to me, but they are giving you a hint that L is the midpoint, so it does create that as equal. We still have to write that statement. I got to translate this, so I'll translate it to ML is congruent to LK, and the reason is because definition of midpoint. And there are other ways this works. It just depends on your textbook and depends on a lot of stuff. But for our purposes, we're going to do definition of midpoint on this. Okay, let's see here. let's see what we got here. It looks like to me that we could also get this. We're going to have another angle side angle, I think, because we got the vertical angle. Anytime we got that X, we're going to have that vertical angle. A lot of these proofs are going to have either that X or that reflexive property where there's shared line. Okay, so let's do this thing here. And let's go ahead and do that MLP angle is congruent to K angle KLJ vertical angle. Let's draw this here. And we'll finish it off with the triangle JKL is congruent to triangle PML. And that is because of angle side angle. So moving on down the road. Okay, let's see if I can get down here enough. Went the wrong way. Straighten it up. All right, cool. All right, we got some right angles. We got bisectors. We have a line bisecting a line. Okay, that's good. So angle B and angle D are right angles. Okay, reason is given. Given. I don't know what that was. And then AE bisects BD. And that's all part of my given. Okay, so let's kind of look at our shape and see what they got going on here and see what to do here. All right, again, we have that X. I'm just going to assume that we're going to use vertical angles, that we're going to need that angle. And this time it doesn't tell me what bisects does. So it says AE bisects BD. So AE bisects BD. Well, we know bisectors go through the midpoint, and so that means this angle and this angle are going to be equal. So it looks like we're got an angle side angle again. There's a lot of these on this particular sheet. Okay, so we're going to move on here, and we are going to we are going to move on, and we got to do the vertical angle here. So angle BCA is congruent to angle, angle BCA is congruent to angle DCE, and this is going to be vertical angle. Okay, so that's an angle. Well, we're going to have to make actually a statement about right angles because we're not using we're going to have to make a statement here. And we did that earlier. So basically this is, we're going to write angle B and angle D are congruent. Or I guess I could have done it like this. And that is because of the right angle congruency theorem. So we could do this in different ways. This is kind of a nitpicky kind of thing, but we can include it. I didn't include it before. We can include it. I just kind of want to show you different ways to get this done, in different ways to think about this. So that's going to be another angle, and then I'm out of room, and this is bothersome. So we're going to do this. We're going to add some paper so we can have this done. I'll just go right here. This part's ugly anyway, so let's add some paper. That's better. So what do we have here? We had angle B is congruent to angle D. And we said right angle congruency theorem. Okay. All right, let's keep going. And then we have that side. Okay, and we're going to call that BC is congruent to CD. And we're going to say that that is because of the definition of a segment. And you need that bisector. And you need that because there's also an angle bisector. And then we're going to finish this off here because that gets us our side. And we are good. So let's finish it off. Triangle ABC is congruent to triangle EDC. And that is because of ASA. All right, we did that. All right, great. Let's get it straight-ish. Okay, I see that right angle again. I'm bothered that I haven't got to do a single HL here. I want to do an HL. Okay, so we'll just try this and see what happens. I really want it to be HL. Angle bisects an angle. See, this is where some people will think they really want to do it because I know I got a reflexive side here. But this line segment bisects the angle, so that's going to create a split in the angle. So this is still going to be that angle side angle. Okay. So here we go on that. And we'll get it done. All right, JM bisects angle J. And JM is 2KL. Okay, and that's given. I'm just going to assume I need to add paper. So I'm just going to get it started right here. If we need to move, we can. Let's move a little bit. All right. So that's our given. So let's translate this into stuff that makes sense. Okay, the first thing, I just want to start with the easy stuff. So I'm going to start with the bisects. I'm going to start with first given. Bisects. So I'm going to say angle KJM is congruent to angle LJM. And that is because of the definition of angle bisector. Okay. Moving on down the road. Let's do the next thing. JM. So, and again, when it comes to this right angle stuff, I'm going to be flexible. That's why I'm showing you different ways. If you do it very formal, like 100% correct, there's options for more points. So I'm going to show you kind of, I need something that translates that into something that makes sense. So JM, I could do JM. That's not what I want. I don't want JM. I want JMK and angle L. I guess I'd have to do it the same way. JML are right angles. And this is the definition, for our purposes, the definition of perpendicular. And what we really need to do for ASA, even though this is kind of I can get the argument, what you really need to do is make that further statement that angle JMK is congruent to angle JML. And that is because of the right angle congruency theorem. Okay, so you might not have both, but you need one of them, something to communicate it. If you got both, that probably will be bonus points. All right, so moving on, spent a lot of time on that one. All right, so we got the bisect, we got the perpendicular. So the angle bisector is an angle, the perpendicular is an angle, and then I got that side in between, which is going to be reflexive, right? So JM is congruent to JM reflexive property. And we'll be able to finish up, maybe. Uh-oh, it's gone. So we'll just finish up real quick. Triangle JMK is congruent to triangle JML. Okay, and that would be because of ASA. All right, pretty good. Let's look at that front side one more time, see if there's any corrections I need to make on my stuff. I don't want to do anything wrong. Okay. And again, this is okay. Probably, I would need to go ahead and make the statement that angle B is congruent to angle D because of the right angle congruency theorem. So I probably wouldn't give myself full points here. But again, if you get something like this, I'll probably give you full points. But if you get the whole thing right, I'll give you bonus. And I think that's the only thing I kind of omitted here that I probably needed. So we had a lot of ASA, SAS, just to kind of break it down. When you come to class, we're going to do some more stuff, and we're going to have some HL, some side. But these are some of the tougher ones to me where we had to translate stuff. And so hopefully this helped you a little bit. And I guess I'll see you next time.